Hello students, welcome back to my channel. In this video, I am going to discuss about combination of resistor. Okay, previously we already studied what is resistor. Resistor is a device which will offer resistance. Okay, so now we will study here what are the ways we can connect more than one resistors. Okay, and if we will connect like that, what is the equivalent resistance of the network, we will see. Normally there are two ways we can combine the resistor. One is series combination and another is parallel combination. First we will see the series combination of resistor. Series combination. The series combination, one resistors, one end is connected to the other resistor end. So listen here, this is a resistor R1, this is a resistor R2. Okay, one end of this R1 is connected to another end of the R2. Clear? This entire network is connected to a voltage source V. Clear? Okay. This is my combination. Clear? So here this voltage source, that is a battery, will supply a current I. And how much is the current that flows through the R1 and R2? For a series combination, current flowing through each element is same. So the current flowing through the R1 is I and the current flowing through the R2 is I. Okay? And so the current is here I and here is to be I and same current is to be registered. Okay? Next we will see what is the potential difference across the first resistor. For series connection, the potential difference is to be different. Okay, if you take like this, from here potential difference across the first resistor I am taken as V1 and the potential difference across the second resistor I am taking as V2. Okay, so what is the potential difference between these network? That is equal to V. That V is equal to what we will get? V1 plus V2. Okay, clear? So what is V1? V1. You see that V1 is equal to, based on the Ohm's law you apply here. Based on the Ohm's law, potential difference is equal to product of current and resistance. That is, the current flowing through the R1 resistor is I and the resistor is R1. Okay, and the potential difference across the next resistor is IR2. This you will substitute here. So V is equal to what you will get? IR1 plus IR2. Okay, this from this you can take I common, R1 plus R2. Clear? Now I am going to change this network as a single resistor. Okay, you see like this. This network I am going to change as a single network. This resistor having resistance R equivalent and the same voltage source I am going to connect. Okay, how much is the current supplied by this voltage source? That is to be I itself. Okay, and the voltage is V. Based on this, how we can write? V is equal to, you will get it as I into R equivalent. This I am taking it as equation number 1. This is the equation number 2. Please equate equation 1 and 2. So what you will get? Here you see this and this is to be equal. So you will get it as I into R equivalent is equal to what you will get? I into R1 plus R2. Okay, I you can cancel, that is R equivalent is equal to R1 plus R2. That is the equivalent resistance when the resistors are connected in series. So if the resistors are connected in series, net resistance is equal to sum of the resistance. Okay. If n resistors are connected, n resistors are connected in series. Okay, n resistors are connected in series, you will get it as what? N resistors. So R equivalent is equal to what you will get? R equivalent is equal to R1 plus R2 plus up to etc. Rn. Clear? That is the n resistor. We will take it as a node like this. That means, I think we can write here node 1. If R1 is equal to R2 is equal to R3 is equal to up to etc. Rn is equal to capital letter R. Okay, sorry, it is not visible. So equal to Rn is equal to capital letter R. Then what is the equivalent resistor? So R equivalent is equal to what you get? R plus up to etc. R. How many times R? N times. So n R will get. R equivalent is equal to n R. Okay. That is the equivalent resistance when the resistors are to be connected in series. Okay. Next we are going to see the parallel combination. The next combination of resistors, that is a parallel combination of resistors. Okay. Clear? Okay. Next, parallel combination. Parallel combination. How the parallel combination? I am taking two resistors. First I am going to take a resistor R1 and another resistance resistor R2. These two resistor, one end is joined together, this is another end is joined together and is connected to a cell. Okay, this is the way we will connect parallel. So from this voltage V, there is a I current is comes here. This I current reaches to here, it is splitted into I1 and it is I2. So you see this here in the parallel combination, current flowing through each component is different. In series we got it as current flowing through the each component is same. Clear? Okay. But what about the potential difference across the each component? You see here. What is the potential difference across R1? That is the same potential difference across R2. That is the way it is connected. Okay. So the potential difference across the resistors are connected, but current flowing through the resistors are different when it is connected in parallel. Okay. So what is I? This I current is coming I1, I2 and it is again reaches to I. Clear? So from this, what is I? I is equal to I1 plus I2. Okay, what is I1? Based on the Ohm's law, V is equal to I into R. I is equal to V by R. That is I1 is equal to what you get? 1 is equal to V by R1 and I2 is equal to potential difference across the second resistor divided by the resistance, that is R. Okay, substitute it here. I is equal to V by R1 plus V by R2. Sorry, this is R2. Okay, clear? From this we can take the V is common. So I is equal to V into 1 by R1 plus 1 by R2. Okay. Now I am going to replace this entire network as a single resistor. This entire network I am going to replace as a single resistor, that is R equivalent, and it is connected to a voltage source V. Yeah, okay. So this voltage source have the same voltage of this, and it will supply the current I. From this V is equal, what you will get? IR. What is I? Sorry, I into R equivalent. What is I? V by R equivalent. So look at this and these equation. This side is same, so that side also same. Okay, here left hand side is same, so the right hand side also same. So we can equate this. So that is V by R equivalent is equal to V into 1 by R1 plus 1 by R2. V cancel. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2. This is the equivalent resistance when the resistors are connected in parallel. Okay. If n resistors are connected, n resistors are connected in parallel, R equivalent is equal to what you will get? That is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus up to etc. 1 by Rn. This is n resistors are connected. Okay, we will take it as a note here. If R1 is equal to R2 is equal to up to etc. Rm is equal to, sorry, here M like that it is, I am taking because series and parallel will be confused. So I will take it as R. What you will get? 1 by R equivalent is equal to 1 by R plus 1 by R plus up to etc. 1 by R. How many times? M times. So 1 by R equivalent is equal to M by R. What is R equivalent? Is equal to what? R by M. So from this what you can see that the resistance is reduced, it is divided by the number. So from this you can see that if the resistors are connected in parallel, the resistance value decreases, net resistance value reduces. If the resistors are connected in series, resistance value increases. Clear? So if you need to get a large resistance, you can combine more number of resistors in series. If you want to get small resistors from larger resistor, you can connect that resistors in parallel. Okay, clear? And very important thing for a parallel connection, voltage value is to be same. Clear? So we will, if you connect any device in parallel, all the device will have same voltage. Okay, so that we can connect all our devices in a home in a parallel. Okay, and any one of that resistor will be damaged. It will not affect the working of the other devices. But in series it is entirely different. Voltage across each devices is to be different. We cannot manufacture like that devices. Okay, I think you've seen that any fan or anything you will buy from there. There it is written as 230 volt. All the device. But if you connect it in series, it may not get that. Okay. And if one device will be damaged, it will be affect the other devices. Okay, that is a problem for the series combination. But parallel combination resistor will be reduces, but the voltage across each resistor will be same. Clear? Okay. So here we will discuss a special case here. If two resistors are connected, what is the net? So here you see that 1 by R equivalent is equal to R1 into R2. that is LCM here, you will get R1 plus R2. So from this R equivalent, what you will get? R equivalent is equal to R1 into R2 divided by R1 plus R2. Clear? Okay, that's it. So by using this equation, if 10 and 5 resistors are connected, we can easily find a 10 ohm resistor and a 5 ohm resistor are connected in parallel. What we can find the equivalent resistor? That is equal to 10 into 5 divided by 10 plus 5. Simply we can, very easy we can find. Like that you take, if R1 is equal to 10 ohm and R2 is equal to 5 ohm, what is that R equivalent? You just directly multiply. That is 10 into 5 divided by 10 plus 5. That is 50 divided by 15. Easily we can find out like this. Clear? Okay. This way we can find out the equivalent resistors of a combination of resistors.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.